Hello everyone, this is Head Pankaj and I welcome you all to new day, new question series. So once again I have brought one more question for you. So as you can see the question is saying we have basically one solid sphere of radius r gravitationally attracts a particle which is placed at the 3r distance from its center with the force of the F1. Now, a spherical cavity whose radius is r by 2 is made in the sphere as we can see in the figure, and the force becomes basically your F2, and the thing which we want to find is the ratio between F1 and F2. So this is the solid sphere we have, this is the cavity we have. So force of attraction between the solid sphere and this mass is F1, and the force of attraction between this cavity part and this M is basically F2. So we want to find the ratio of F1 and F2. So what I have done, I have already redrawn the diagram which we have given in the questions. Okay, so let's see which key concept we can use here. So what I am going to do here is, first I will find the force of attraction between the complete sphere and the mass which is basically small m. Okay, so force of attraction between complete sphere and small m, and this is nothing but the F1 as per the question, which will be equals to G capital M, because mass of complete sphere is capital M, small m, upon distance we have between the center of the complete sphere and small mass m is basically 3r, because this value or the radius which we have given for this small cavity sphere is basically r by 2. So if this part is r by 2, this part is r by 2, complete will be r plus 2r will be basically 3 times of r. So it will be 3r square, which will be G capital M small m upon square of 3 is 9 by r square. So I am going to name it as a equation number 1. Now listen everyone, here what will happen if I directly find the value of F2. So basically F2 is the force of attraction between this cavity and this small mass m. Now what will happen, as we have removed this part from the sphere, the center of mass which was earlier here, now it will shift somewhere here. So because of that, the distance which we have between the center of mass of this cavity part and center of mass of this small m, it will change. So it will be very difficult, because we will have to use the concept of center of mass, then we will have to find the value of force. So instead we can do one more thing. What I will do, I will find the force of attraction between this removed part and this small m, and simply I will take the subtraction of the force because of the complete sphere and force because of this small removed sphere. Let me show you how how we can do it. So for this, what I will need the first mass of the removed sphere. So let's try to find mass of removed sphere. I'm going to name this as basically m dash. Now I know that mass is equals to basically volume into density. So original mass was capital M, which is mass of complete sphere, mass of complete sphere, which is nothing but the volume into density. Volume will be 4 by 3 pi r cube into rho. This is the value of m we have. Now m dash is the mass of removed sphere. Now both are made up of same material, so their density will be same. So again, mass is equals to volume, which is 4 by 3 pi. Radius how much we have? It is basically r by 2 radius we have. of the removed part. It will be basically cube, not square, because we are finding here volume. So 4 by 3 pi r by 2 cube, and density will be same as it is rho. So final answer will be 4 by 3 pi r cube. Cube of 2 will be basically 8 into rho. Now we know that this 4 by 3 pi r cube into rho is nothing but your capital M. So it will be M by 8. Now force of attraction between removed sphere and small m. I'm going to name it as a F dash, which will be G m dash, which is the mass of the removed sphere, into small m, and distance will be, let's see the distance. Distance will be basically from here to here. So as we can see, this distance is 2r, this distance is r by 2, so complete will be 5r by 2. So distance is basically 5r by 2 square. So G as it is, m dash is basically your m by 8, small m, square of 5 is 25, square of 2 is basically 4 into r square. So 4 ones are, and this is basically 4 twos are. So F dash will be G capital M small m upon 25 into 2, which will be 50 r square. Okay, now last step, that is force of attraction between small m and complete sphere is equals to force of attraction between small m and removed sphere plus force of attraction between m dash and sphere with cavity. So the first force of attraction between M and complete sphere is nothing but basically your F1. Force of attraction between M and removed sphere is nothing but the F dash, and force of attraction between M and sphere with cavity is nothing but the F2. So what we want to find? F2, which will be equals to F1 minus F dash. So what is the value of F1 we have? Value of F1 we got G capital M small m by 9r square. G capital M small m by 9r square. Whereas F dash, how much we got? G capital M small m by 50r square. So as we can see, we have G capital M small m by r square common. So in the bracket we will be having basically 50 minus 9 by 450. This step I have performed directly, like I have taken the cross multiplication. So finally it will be 41 G capital M small m by 450 r square. This is the value of F2. Now what we want to find? We want to find the ratio of f1 by f2. So value of f1, how much we have? G capital M small m by 9r square, whereas f2 is basically 41 G capital M small m by 450 r square. Now this G capital M small m, G capital M small m, r square, and one more thing, like this 9 ones are and 9 50s are, because 9 5s are 45 into 0. So final answer will be 50 by 41. So let's check the options. So any option we have with the 50 by 41, which is our option number second, which will be the correct option. Okay, thank you.